Of course, we also need to be able to construct a confidence interval for the mean of matched pairs differences. And again, the formulas are tricky, so we're not using them. But I will notice that you might want to select save differences when you do this. And we're actually going to do that in this particular problem. It was actually in the hypothesis test as well that that's an option, but we didn't bother because the Reiki therapy was so easy to figure out, we didn't bother. But in this case, we are actually going to do it. All right, and don't forget that this little piece right here is the new piece, the dependent piece, because this is dependent data, paired data. All right, so let's look at an example of some paired data. So the 2008 Olympics were full of controversy about new swimsuits that possibly provided unfair advantages to swimmers, leading to new international rules that came into effect January 1st of 2010 regarding swimsuit coverage and material. A study tested whether wearing wetsuits influenced swimming velocity. So a random group of 12 competitive swimmers and triathletes swam 1,500 meters at a maximum speed twice each, once wearing a wetsuit and once wearing a regular bathing suit. And the order of the trials was randomized, so you don't have to worry about them getting tired. That's not what was impacting what was going on. So each time the maximum velocity in the meters per second of the swimmer, among other quantities, was recorded. Okay, so why is this a dependent sample? Well, this is obviously one group of swimmers measured twice. Right? They were measured with a wetsuit and without a wetsuit, right? Wetsuit versus no wetsuit. Okay, so let's find the differences and find all these values. And I'm actually going to kind of do this out of order a little bit. So I know it says to do all of this right now, but let's look ahead just a little bit. We're actually going to be constructing a confidence interval here. So I'm going to sneak part E in right now. Because if you want to find the confidence interval, it says stat t-stat paired and select save differences. So I'm going to write that right here. I'm going to skip to letter E real quick. So we're going to do stat t-stat paired. And we're going to click save differences. We don't really need the save differences part. I'm just reminding you. Okay, so let's do that. And then when we do that, it'll find all these differences for us, and then we won't have to bother. Okay, so I've got this data set, same data set we worked with for before and after. So the wetsuit versus not wetsuit is right here. So if I go to stat, t-stat paired, column 1 was wetsuit, column 2 is no wetsuit. I click the save differences button right there, so that'll turn that on. And I'm going to scroll down here and I want a confidence interval, and I think we want a 95. So 95 is perfect. So we say compute. Now did you see it? Automatically over here, over here to the right, it put the differences in. And it has the confidence interval, which I can kind of, I can move that around. But these differences right here, that's key. That's the wetsuit differences. So I want to put all of those numbers on my sheet of paper for letter B. So right here for letter B, I'm going to write all of those values from the StatCrunch. And you guys do that also. I'm going to pause while we do that. Okay, those values are now all on my sheet. All right, so now I want to find D bar and ND and SD and all these other good things. Well, if you were paying attention, you might have noticed that StatCrunch actually found a few of the things. So the mean is right here. The standard error, that's not the standard deviation, but the standard error is right there. And the degrees of freedom is right there. So I actually know a couple of them right now. I know the degrees of freedom is 11, and I can fill in these other three values right now. Okay, so if I go back here, I know that this value was the difference, and I know the standard error, right? That's what this stands for. Standard error. That's chapter 8, right? Section 8.1, if you're interested. Okay, oops, that's a section symbol. Okay, so degrees of freedom was 11, but N, we can actually count for ourselves. It was 12, right? So this is 12 swimmers right here. N is 12. Degrees of freedom is 11. Technically, StatCrunch found it, but we also know it's 12 take away 1, right? So, or if you like, 12 is 11 plus 1, right? These have to be 1 apart. The degrees of freedom is 1 smaller. So I don't know why I gave us such big blanks for these. That was unnecessary for those ones. I'll fix that for future. Now, the one thing that StatCrunch didn't automatically find for us was the S. That's because that's not standard error, that's standard deviation. Well, how do we find standard deviation? Well, we already did this. It's stat, summary stat, columns. We have all the differences sitting in a column. So we could find all these values actually with that instead. I know that this result actually found a bunch of them for us, but we could actually have done it ourselves. Stat, summary stat, columns. Now you want to make sure you choose the last differences you have, because the last one right there was the one for the wetsuits. The one before it was actually the one for the other problem with the Reiki therapy. All right, so we wanted the mean, we wanted the standard deviation, we wanted the N. It doesn't do degrees of freedom. That's not in here, but it does do standard error and say compute. And there you have it. So you can see the 0.0775 matches, the standard error matches, but this one will give you N instead of degrees of freedom, right? And then now we have the standard deviation. So it's 0.0218. And if you're interested, it would have the same unit as the data set. So this would be meters per second. This would be meters per second. So this is actually swimmers. Right? And degrees of freedom, it's it's more a generic number thing, but if you want to think of it as swimmers, that's fine. So it has the same unit as your N. But we don't really think of degrees of freedom as having a unit generally.